Hello everyone, welcome back to this channel, and today we're gonna start off a new series called Advanced A-Level Computer Science. We're starting from chapter 16, and in this video we're gonna look into the advanced version of data representation. So this is how the chapter looks like. First we'll talk about what data type is and how are different types of files being stored and accessed. And lastly, we'll learn how to use binary to represent real number, which is decimal numbers in mathematical term. By the way, if you like my videos and you have not subscribed yet, I would appreciate it if you could hit the subscribe button, because there are over 70% of you who have not subscribed yet, and that will be the only favor I ask from you. Thank you so much. So let's move on to data type. So this is the topic that we mentioned briefly in the programming chapter, but why is data type important to the computer? Look, data type tells the computer the type of data that a variable can store. So I just want to give you an example here. When we are learning about data representation, we know that we can represent character using ASCII, and we can also use binary to represent numbers in denary. And this byte of binaries here, it can mean A in ASCII, or it can also mean 97 in denary. Therefore, it is important for the computer to know, alright, this byte of code, is it used to represent a character or is it a number? And then only then they can interpret accordingly. So this is a few data types I want you to know. There are two types of data: built-in data type and user-defined data type. So built-in data type are predefined data type provided by the programming language. So the programming language will define the following stuff: the range of possible value. For example, Java integer data type, this is the range that is acceptable. And what operations that are available for manipulating values assigned to that variable. So if you were to add up characters, you get a concatenation of it. But if you were to add up numbers, you get, sum of the number. Whereas the other type of data type is called user-defined data type. And one of it is that you can create user-defined data type in Python using classes, something we'll talk about in a few more chapters. Basically, you create your own type. In this example, I create a type called point, which represent coordinates. Like there's an x value, it's a y value. Now, there's also something called a composite and non-composite data type. And the composite data type refers to data structure that contains multiple values. For example, array, list, dictionary. So these are the data types that inside one data type, it contains many other different primitive data type. And in pseudocode, we create something like record data type. You can see that it has many different data types like string, value, real, date, boolean. So this is called composite data type. Similarly, in Python, we can create a class. Whereas non-composite data type, known as primitive data type, represent a single value and does not have internal subcomponents. So one example is integer, floating point numbers, character, boolean, and enumerated data type, which is something we'll talk more on the other side, which is here. What is enumerated data type? It is a user-defined collection of name constant value that represent a set of related items or options, meaning that this particular data type, they have a fixed amount of possible values. For example, I can create an enumerated data type called days of week that contain only Monday to Sunday, RGB color, red, green, blue. And this is how I create data type like that in pseudocode. You can see that if I were to assign the other day like 5th day, then it wouldn't work because it is not part of the enumerated data type. Okay. By the way, a note here is that this is not a string. It's called enumerated. Okay. And this is how I do it in Python. You will first need to import the enum class, and then you can create a class called day of week, and then create a new variable using this enumerated data type that has limited number of values defined by you. The next type is called pointer data type. It stores the memory address of another variable or data element in the computer memory. So if we look at this example here, line by line, so we can first create a pointer type that points to the integer data type. And in pseudocode, this is done by the upper arrow, not sure that's right, the upper arrow symbol that will point to the integer data type. And when you declare a variable, you want the integer data type, that's when you can use the type that you just declared, which points to integer. Declaring variable, so this is basic one, how we declare variable and assign a value to it, and assign the address of number 1 to my integer pointer. And if you want to find out the address which a variable is stored, that's when you use the A symbol. Alright, and then you can dereferencing it. Dereferencing means that, look, we are using the mine integer pointer, which contains not a variable but an address. But then if you want to get the value within that address, that's called dereferencing. You can use this upper arrow here, and it will then take 100 out of this pointer, multiply by 2. So number 2 is actually assigned to 200. I know it's a bit complicated. You might say, what's the point? But then this is just an example that I want to show you to illustrate what how to point to a data type, as in then how to get an address of a variable, and how to dereferencing an address. Next, set data type. In programming, set data type is an unordered collection of unique elements without duplicate values. And set is unordered. It has unique elements, and it is also unstructured, meaning no indexing can be associated with the elements in the set. So this is some examples. Some of you might have learned it in mathematics. Alright, and what some of the set data type operation, meaning once you created this data set, these are operations you can do. You can check if a value exists in a set, and you can add a new data value, remove an existing data value, adding one set to another. And this is how I do it in Python. Basically, I create a list, and to convert it to a set, you can just use a set function. And what it will do is that this set function, it will contain only the unique element. The duplicated one will be removed. Okay, if you want, you can convert this set back to list using the list function. With that, you will have removed all the duplicated item inside your list. So another thing you can do is called intersection, meaning you find out what is the common elements that both sets have. And this is the code used to find the intersection. You feel free to copy and paste to use it. Now, that's all about data types. Hopefully now you have a better understanding. Let's move on to file organization. What are the different types of files? You know, files are used to store data. What are different types of files used to store data? So we'll look into all types of files is stored using specific binary code, 0 and 1, that allows the files to be used as intended. Now we have different types of file called the text file, which is stores data in human readable format according to character code. That's the TXT file normal one. Whereas a binary file stores data in a format that the computer can interpret directly as a sequence of bytes. So the organization of binary file is based on the concept of record. So let's say I have a file here. This file will have 2 records, and within each record it will have fields, and also what's the value of that field. It can be a bit abstract to look at like that. Therefore, I provide an example. Let's say for an image file, the record would be what is within each pixel, and the field would be what is the red, blue component of that particular pixel. Okay, it could be RGB, green also can be involved, but then this is just an example. Pixel 1, Pixel 2, Pixel 3, Pixel 4. Whereas the audio file could contain, each record could be like the first millisecond of that voice, what's the amplitude, what's the right amplitude, and second, third, fourth, so on and so forth. So that is how I do to help you understand the concept of record and field and value. Now let's look into the 3 different types of files that is mentioned in your syllabus: serial file, sequential file, and direct access file. And we'll learn how file deletion and access work in all 3 different types of files. So serial file is a file organization method where records are arranged in a linear sequence, one after the other. So real life scenario when serial file is used is that daily transaction logs in a financial institution. Each day, the institution records transactions sequentially in a log file, appending new transaction at the end. Whereas sequential file is when records are arranged sequentially and accessed in a predefined order. There's an order we want it to maintain, typically from the beginning to the end. And modification often require rewriting the entire file, meaning if you want to sort it, then you have to rewrite the whole file. Real life example, order processing. You want to know which order comes in first so that you know who to ship the product to first. The next one is the fastest type of file called direct access, a file organization method allowing data retrieval or storage at any location within the file without needing to sequentially traverse the entire file. So for both serial and sequential file, to find a particular record, you need to go through this entire file one after the other. Direct access means you can directly access a record without going through the file from beginning to the end. Now, how do we achieve direct access? The first way is to use a sequential file with a separate index file. So look, this is my table here. So instead of going through the record one by one, I can create an index file that stores ID in ascending order. And then this ID here, it has another column called pointer, which points to the specific record. Meaning that once we get the ID, we can just traverse through this list, which is sorted, which is easier to find. And then once we find the record, we can look at the pointer and then point us directly to the record that we want. In this example here, it says that scanning through the index table is a lot faster than scanning through the entire table due to the usage of efficient data structure, which we'll learn in the future. But in essence, it says that going through here is faster because it's sorted. We can use some specific technique to make the process a lot quicker and effective. The second way to achieve direct access is to use a hashing algorithm. What hashing does is that it takes in data as input and produces an output that tells us the location which we should store the file. For example, my hashing algorithm, I created a simple one. Let's say my algorithm is that I will divide the number by 10 to get the remainder of the ID. And that remainder will be where I store the file. For example, 2076, if you divide by 10, your remainder will be 6. And this is when you put this record into this file location 6. And with that, you can see that different records are put in different types of the file. And this allows direct access, meaning if you want to access a file, you just find the remainder of the student ID when it's divided by 10 and just go to that location instead of traversing one after the other. Now, of course, a collision could happen when the ID has 7 as the least significant figure. This is when what we call collision. And one way to avoid collision is that we need to use a good hashing function. Mine is really bad. This will prevent collision. In other words, we minimize it. They produce hash value that seem random without predictable patterns. So one of the methods is to use prime number of a similar size. So this is something that you will learn when you started coding hashing algorithm for the next few chapters. So dealing with collision, there are a few ways. Implement a sequential search method to locate an empty address immediately following the calculated position. Meaning once you got a collision, you just do a sequential search after the current position to find an empty slot. Or you can reserve a set of additional address at the end of the file to accommodate overflow data, meaning if there's a collision, move the file there. Establish a linked list accessible from each address for efficient data retrieval and management. Now, of course, sometimes we might not have numbers. Let's say you want to use names as the input to your hashing algorithm, then we can use the ASCII code for the alphabetic characters. So this is just a side note to help you understand how to use it. Now, file access for the different types of file will also be different. Access occurs sequentially from start to end with data retrieved or appended in a linear order. That's for serial file, very ineffective. Sequential files also take place sequentially, but if the key value is known for the record containing the one's data, the process is faster because only key field value needs to be read. Instead of all the columns, you only look at one. Direct access is pretty fast, easy. You just use the hashing algorithm, reverse the process, and find the place which stores the data you want to. And of course, just now as mentioned, collision could happen. This means that you might need algorithms to handle the collision properly. Whereas for file deletion, involve marking the records as delete for serial file. Sequential file, this is a bit tedious, meaning because the data need to be transferred from the old file to a new one until the targeted record for deletion or modification is encountered. and after which any changes are made and the remaining records are then copied to a new file. So that's sequential file. Direct access file involve marking the specific location as available, meaning we don't just take out the data, we simply mark it as this is available, meaning if there's a collision in the future in that particular spot, then it can replace the value directly. Now, choice of organization, like which type of file should you use. For a serial file, use it when data needs to be maintained in a chronological order or when continuous appending of data is required. And sequential, use it when data needs to be processed in a predefined order. Direct access if you want to access a file in a very quick manner. So direct access should be the ideal file if you prefer quick speed. Now, the third part of the video talks about how to represent real number. So far, we have learned how to represent numbers, negative numbers using binary, but we haven't learned how to represent real number like this decimal point. Now, to understand how to use binary to represent real number, you need to understand how a decimal number can be written in different type of standard form. These are three ways are equivalent to 64.7. So these are the only sensible choice we can encode it into our program. And I want to show you the first method, which is not the best method, but then hopefully after this segment you can appreciate the latter method. It's called fixed point representation. So it's a numerical format used in computing where a specific number of bits are allocated for the fractional part, which is the decimal point, and integers, meaning I allocate 4 bits, for example, for a whole number, 3 bits for fractional part. That's why it called fixed point representation. The number of bits is fixed. So for example, if I only have 8 bits, then I need to allocate 1 bit for sign bit, positive or negative, 4 bits for whole number, 3 bits for fractional. So if you were to use 3 bits, these are the only possible decimal point you can get. So 000 represents 0.125, 001, 0.125, meaning one step is equal to 0.125. Of course, using this method, let's see, if I have this byte of code here, so this byte of code stands for negative 11.75. So you can see 101, if we refer to the tables, it is 0.75. So hopefully now you can see that if I were to increase my bits for fractional part, I will have more choices regarding on what I pick. So using 8 bits, let's do an analysis on what's the largest positive value and negative one. So the largest positive value that it can represent is 15.875, smallest 0.125, and negative value negative 1.25, and it's the same. So you can see that the range is not very big, and if you have something special like 14.99, it can't be represented using 8 bits fixed point representation. So this is when floating point representation comes in. It's more flexible, but it can also be a bit harder to understand, but it can represent a bigger range of number. Now, how floating point representation work is that it has the term mantissa, exponent, and r, which is the base implied to. Now, what happened is that in this method, we want to specify bits used to represent mantissa and the other bits used to represent the exponent. For example, 4 bits to the mantissa and 4 bits to the exponent. Let's look into the mantissa part. For now, it can be a bit harder to understand, but let me finish the whole picture, and hopefully at the end of it, you'll understand it. So there are multiple ways we can, let's say we are using 4 bits to represent just the mantissa. And if there are many ways to organize where the binary point is, meaning where do we put the point part of it. So if I were to put the point part, that means I use 3 binary digits for integer and 1 for fractional part, then these are the only possible value. The fractional part can only be 1 or 0, therefore I can only have 0.5, 0.0. And integer part, I can only have value from 0 to 4, because I need to use 2 bits for the integer and also the leftmost bit as the sign bit here. So these are the 3 largest and 3 smallest representation for if I put a floating point binary point here. But if I were to move the point to this side here, meaning I only have 0 because I don't allocate any bits for the integer, and that's the sign bit. Look, I had not if when I have more bits for fractional, then I can have more choices in regards on how instead of just 0 0.5 and 1, 0 0.0, I can have 0.125, 0.25, 0.7375. So again, this is the largest and smallest representation. Of course, if you don't want any point, you can also use all the bits just for the denary. Now, let's look into what we can do with this floating point representation. What can we represent? If you look here, let's say the leftmost bit is the sign bit, and this is like the 3 bits we use to represent the mantissa values. You can see that the largest possible value, imagine that I'm using all the bits for floating point, meaning like this fractional, and these are the largest positive value I can represent. So you can see that E uses 4.2 to the power of 7. So the biggest number I can represent is 112. And the smallest positive number, after calculating it, I got 1 over 2048. Whereas the smallest one is also the same. Now, you can see that this is how we do it. So basically for exponent, this one is also the sign bit. If we were to compare fixed point representation that we do at the beginning and floating point representation that we do at the end, you can see that floating point representation, even though it's more complicated, it can represent a larger range of values. Now, again, we are not done yet with floating point representation. I still want to show you how to convert a floating point to using floating point representation. So let's see. First step that you need to understand is called normalization. To achieve maximum precision, we need to normalize a floating point number. In practice, the largest possible magnitude for the value represented by the mantissa will achieve optimum precision. So what does it mean? So for denary 2, these are the following form that represent denary 2. They are all denary 2, okay? But then you can see that it's the last row that has the biggest mantissa. Okay, so this is denary -4. That is when we increase the mantissa value, like from 125 to 0.5. As we increase it, it will achieve more precision for us. And when the number is represented with the highest magnitude for mantissa, the 2 most significant bits are different. So if you look at this, the 2 most significant bits, they are both 0. This means that the mantissa value is not at its maximum. Whereas 0.5, you can see that the first 2 bits, they are different. Similarly goes to -4, 1.0. The 2 most significant bits are different. So what we want to achieve is that we want the mantissa to have the 2 most significant bits different. So let me explain how to do it. We keep decreasing the exponent, and then we increase the mantissa to achieve normalization. So this is the same thing for denary 2. I keep increasing it until I got the 2 most significant bit as different. Denary -4 is the same. Go down, keep going down 1 step at a time. Now, let's do some conversion to really understand the whole thing. I know that most of you might feel very confused. Hopefully after this part it will be fine. Now, let's convert 9.7 to floating point representation. So to do this, we'll convert the whole number part first. We'll add a leading 0 to it. So 9, if you convert it to denary, it will be 1001. And we add a leading 0 to it. And then we'll convert the fractional part, 0.75. You know that we can use 1. So if we were to use only 2 bits, this is something we can represent. So after that, you combine step number 1 and step number 2 using a point. The next one is when we want to normalize it to achieve maximum precision. So I'm gonna move everything to achieve 10 to achieve normalization. So meaning I'm gonna move the point, go 2, 3, 4. until that the first 2 bit is 1, 0, and 1. So this is how I move my binary point. And after that, this gives an exponent of value of 4, meaning we shift the point 4 times to the left. So assuming that 14 bits are allocated, 4 bits, 10 bits for the mantissa and 4 bits for the component, this will be our floating point representation. So 0, 1, 0, 0 is the exponent, mantissa, whatever we calculated here, we add 4 bits to it to make it like a 10-bit. So can you see how I got the exponent? Okay. Now let's convert another floating point representation, which is like 9.73, which is a little bit harder to do because we can no longer do this part. So let's try to do. Again, we convert the whole number part, 0, 1, 0, 0, 1, add a leading 0 to it. And to convert the fractional part, the method is that we keep multiplying it by 2, and then we only record the whole number part. For example, 0.73 multiplied by 2, I got 1.746. I'll keep the 1. And then, followed by 0.46 times 2, 0.92, I'll keep the 0. 0.92 times 2, 1.84, keep the 1, keep the 1. Then I will have gotten my fractional part, 0.1011. And then combine the two parts, the whole number part and also the fractional part. And again, we move the floating point, the binary point, until we see the 1, 0 part. Okay, so looking at this example, we move 4 steps. So this gives an exponent value of 4, meaning we put our exponent value as 4. And assume that 40 bits are used. I basically just add everything to it. 1001, 1011, there are 8 bits, so I add 20 to it. Okay, so 10 to it to make it a 10-bit. So this is my mantissa and component exponent to represent 9.73. Now let's try to solve negative. Last one of the video. Persevere. So started by converting 7.75 to binary. 7, 1, 1, 1, add a leading 0. 7, 5, use 1, 1. Combine the two part. For negative, 1 is a little bit different. We need to convert to 2's complement form. Firstly, you convert first to 1 complement. Basically, just invert all the value. And then 2 complement, you add 1 to it. And then move the binary point values until you see 1, 0. Okay? After that, since we move 4 times, the exponent value is 4. Then you just add a few bits to make this mantissa a 10 bits mantissa. After that, add everything together, and that will be your floating point fixed floating point representation for negative 7.75. Alright, problem with using floating point numbers, approximation and rounding errors. So this, as you can see, we are approximating a lot. Alright, and also another problem is that there's limited range of numbers. And this might mean that we might need to use a lot of bits to represent the floating point. Okay, so that's something that you can read to understand what's the problem with floating point number. And that's also the end of this video. I know that the floating point number can be a bit harder to understand, so just watch a few more times to understand the gist of it. And with that, I will close off the video. Thank you so much for watching. I'll see you in the next video. Goodbye.